Alright, in the next step here, the idea is you've got the variance between groups at 24, you've got the variance within group at 1. The final step is to compute an F-score, which is the big kahuna here. 24 over 1, your obtained F value is 24. So does that sound like good news to you? Let's have you turn to page 705 of your book. You have to look up and see if it's significant. So if you get an F-score of 24, what you basically have to do on page 705 is look at degrees of freedom for the numerator. Well, how many degrees of freedom do we have for between groups? We have 1. How many degrees of freedom do we have for the denominator, the within group? We have 4 there. So the critical score for 0.05 is 7.71. For 0.01, it's 21. And so what you could basically do here is we are statistically significant. I'll just write out the basic APA statement is F, and then you write in parentheses the degrees of freedom numerator and denominator, 1 comma 4 equals 24. I just wrote here P is less than 0.05. You could actually write even P is less than 0.01 if you really wanted to. So we got this result. It's statistically significant. So what would be the real world conclusion? Yeah, the drug improves memory. The final thing I wanted to do, at least with this particular one, is to compare our T result to our F result. Go back and look at that F result from way back when. Notice what we got on the FT score, 4.899. Do you think there's any relationship between the T score and the F score? Well, if you take the 4.899 and square it, you'll get 24. T squared equals F. Because we basically were doing the same thing as we were doing with the t-test, but it was a little simpler for the denominator, the sums of squares within groups. So if you take a t-score and you square it, you get the f-score. If you ever get a negative value for an f value, you know you've done it wrong. But t squared equals f. Now, the final thing I wanted to do here was kind of look at the SPSS printout of the same thing, because SPSS will do this for us. Let's look at this screen that SPSS gives for us. If I were to input the data in, and I'll be showing you this at the end of the term, we could put in the between groups, and this should basically map exactly what we just did. The sums of squares between groups was 24, because that's 3 times the quantity 6 minus 4 quantity squared plus 3 times the quantity 2 minus 4 quantity squared. We want that number to be large. That number reflects the treatment in terms of the drug. We have 1 degree of freedom there. Notice it calls it a mean square, but that's really the same thing as variance, because it's the sums of squares and then it's kind of a mean for that. Although you could also say it's a really mean square. It's a really nasty, mean square, and it doesn't like you at all. Maybe not. So the variance between groups is a 24, and then it gives us the sums of squares within group. That was 4 because we have 3 consecutive numbers in both groups. We always want that value to be low because that reflects the error. We have 4 degrees of freedom within group because we have 3 in the first group and 3 in the second. Then we get the variance within group at 1. The F score is 24, and then the computer actually tells us the probability of getting this according to chance is 8 out of 1,000. Which is just like what we computed by hand. If you were to get this particular printout, though, you'd write F of 1 and 4 equals 24, and then the probability 0.008. So hopefully this makes sense to you. What I'd like you to do for a homework problem is basically a very similar situation here. You should be able to figure out some things just looking at it. 0, 1, and 2, and 10, 11, 12. If it's too difficult for you to show me with a graph, you don't have to, but basically graph and assess yourself, the 0, 1, 2, the 10, 11, 12, like the file I did. See if you can figure out what's going to happen here. Then compute the variance between groups and the variance within groups. Get your F ratio, look in the back of the book, see if it's significant, and then write out the statistical and real-world findings. Okay, thank you all very much. That'll do it. Bye-bye.